Hello friends, welcome one more time in this session. So far you have seen my sessions on topic light and optics in physics, which was mainly through slides and it part 1, part 2, part 3, and it covered all basic properties of light like reflection through plane mirror, reflections through spherical mirrors, and then refractions through plane surface, reflection through uh, curved surface, then lenses, then prism, right? So it was part 1, part 2, part 3, and each section, each part had its own level 1, level 2, level 3. Level 1 meant for junior guys, and then middle and senior guys, right? But in previous sessions, my broad level objective was to talk about basics and then some derivations resulting to some important key formulas which is to be used in numericals, and then use cases, where mirrors are used, where lenses are used, and all that, right? It was like, for me, it was like a narrating story, right? And you are just swallowing that, right? So definitely it would have answered your, the basic fundamental questions. I always talk about what and how, but we never answered why. Okay, every bit of uh, word I write, you should ask why. So I believe that order of these three fundamental questions should be what, how, and why, not what, why, and how. Reason, until unless you have an overview of anything, you will not be able to ask relevant whys. That's very important, and that's how sometimes people get stupid. And they are ashamed of asking questions. But in theory, it's all very well instituted thing, right? People should ask why, and otherwise you can't understand anything, right? So, but I always tell my folks that you should ask why till you get to the level and you actually know overview of it, and then ask you know good whys and get to the concept. If you start asking why at every moment in the beginning, you will not be able to proceed. So I think you should just accept it and just go through it. But without going through why, you should not think that you have completed your topic or any subject, right? So that was the thing. But this session, I'm sorry, I'm taking stretching this topic, but just to give you analogy and explain you why I'm taking this session, and this is a different session. This session we call it a capsule course. Okay, capsule course for each topic. So if you go through this course in 1 or 2 hour session, you will be able to uh, learn very well the whole chapter, and then you become a confident student, right? And you will not be nervous just before exam, because I'll tell you what happens. People just go through that, right? And read all books, many books, and finally they mix up, right? And when before and when anytime they try to remember, okay, what I studied, they start they get start boggling about it, right? So with this, what I wanted to you know explain, how do you store information about any topic in in your memory, which uses your minimum memory, right? And there's a basic fundamental behind that. You should never try to store, for every new thing you should never try to store a full-fledged explanation. You should see what is basic and then what is delta. Basic you might have already learned in some other scenario, and what is how is it different from previous one. So you should try to learn only that delta and store it, and that makes you building. That makes you more confident that okay, you can walk through. You take it from there and take it from some other places and club it, and you can design a new thing, right? So that's how you should do it, and that's what I would try to explain you. So I mean, again, coming to analogy, right? So first time, if let's say take example, first time you have to teach about, or you have to explain a toddler, maybe a or young kid like 6 years, about animals, right? So if you read a book, right, how do you feel and how does the guy feel, right? That kid feels. So if I go and explain on paper and draw pictures and tell them a cow has 4 legs, one tail, one mouth, and we draw the picture. And similarly, I go and explain about lion and buffalo and horse. So and I talk about the cow gives milk, lion does hunting, and he he lives in jungle, cow all that I explain, but still he will not be able to understand everything where he can uh, he feels very confident, right? And he can articulate again, or he can identify those animals when they see them. I mean, that's whole idea, right? You should be able to identify without seeing that, because we have never shown them a real picture or sketch diagram with colors, right? A three-dimensional picture. So capsule course, the first session actually brought you, I mean that brought you a sketch diagram of the topic, okay? And this capsule course would allow you to feel those subjects in your own language, on that topic in your own language, and you will understand second fundamental question, why. And once you understand why, you can articulate whole thing in your language, and you can give a different meaning to that topic. And that is what we call scientists, they do it. I mean, I've gone to the very high level, but that's what I'm saying, and you never feel nervous about it, right? So the capsule course will talk about why. Okay, so let's take an example of plain mirror and a spherical mirror. Okay, so let's come to the point. These are three basic formulas of a spherical mirror, which all students remember by heart most of the time if they have gone through whole chapter one or two times, right? So you'll remember this, you never forget this, right? F focal length is equal to r by 2, radius of curvature, divided by 2. 1 by v plus 1 by u equal to 1 by f. V is your distance of image from pole, u is distance of object from pole, and f is focal length. And then m is magnification, which is I by o, that is size of the image divided by size of object, which is equal to minus v by u. Now problem is, you can use these formulas solving simple numericals, not the typical ones which are little more tricky. But anytime, if it is not towards the examination, when you are, if you have gone through all chapter one more time, till then in between, if I anybody asks, can you prove these formulas, right? You have seen most of the students start sweating. I mean, they think, they start feeling, oh my god, I need to revise one more time, right? I need to revise one more time. It all, one page detailed description, starts coming in mind, and they don't know where to start, where to finish. I mean, they get nervous. And actually, if you don't know derivation of these formulas, first thing you don't feel confident, and then tricky questions start from there, right? We'll come to that. So I will talk about how do you remember these formulas or any formula in your any topic all the time, right? You need to follow some techniques, right, to remember them all the time. And once you remember, you know exactly how does it come. You actually know the subject, right? Because wherever they do a twist, you can branch out from that step and do whatever is required there. Otherwise, you just know these formulas and you end up putting wrong values, or you end up doing something which is not supposed to be put here. And then, but simple things you can do. So all the time you should remember this on this formula. At least that much if you know, you feel like 50% you know. So basic f equal to r by 2. How do you prove that, right? So let me take example of concave mirror. Okay, this is P, pole, left side is reflecting surface. Okay, and this is your C, center of curvature. This is your F, focal point. And let's say you have a point object here, which is called O. Okay, so now, not point object, I think let's take a rays, because we have to prove f equal to r by 2. So we know a basic concept that line rays of light coming from infinity, which are parallel to principal axis, they go through a point at a common point. They intersect all at a common point, which is called a focal point, and distance of that focal point f from P is equal to r by 2. So we are going to prove that. We are not saying, we are saying they go through a common point which intersects at principal axis, right? So let me join, let's say this is point E, let me join C to E. Okay, because C is the center of curvature, this would be this would be a normal to that plane mirror, sorry, that spherical mirror at point E. You know that, right? Radius is always normal at perimeter, right? So rays coming from infinity, they form, let's say, angle theta. So angle of incidence equal to angle of reflection. So this would be also theta. Okay, and I don't know, I mean, I'm saying it's not f here. Let's say assume this is some different point, and we'll prove, we will define that this is a point where distance this will be equal to r by 2. And now definition, we will give this definition to a focal point. Okay, this is theta, right? These two are parallel lines, so these are alternate angle. This would be also theta. That makes this triangle ECF, an isosceles triangle. Means these two sides CF should be equal to EF. CF should be equal to EF. If CF is equal to EF, because these two angles are same, for a special case when the aperture of this mirror is small, what does it mean? It is not that big. We cut a small portion from a sphere, very small, and that looks like kind of straight, not straight, but very, you know, so these point E and P would be actually very near, and in that condition only, for a small aperture, EF would be equal to PF, right? And so that says CF equal to PF, CF equal to PF. So F is a middle point of PC and PC is your radius of curvature. So F is a set at center. If you take any other parallel line, parallel ray coming to the mirror, parallel to principal axis, that will also cut at this place, right? So that's observation, and we proved that they will be all cutting at a common point, and that's called focal point. So actually, remote object at infinity, that will form a point image, very illuminated point sharp image at focal point F. So we proved that F is equal to R by 2. We did not use any other law except which you know about plane mirror. And actually I am not talking about plane mirror. I can prove why I should be equal to R. So if I talk about plane mirror, I can prove that also. You don't need to mug up anything. We knew it and we proved F equal to R by 2. But what was caveat here? Caveat was for small aperture. So this mirror is a small aperture. That is the point. You need to remember always. If you miss that, if they give any problem where mirror is big and you use these formulas, it's wrong. Okay. So these are called caveats. Now let's go to next formula, which we seem to be always it seems to be very difficult, and always all students mug up just before exam, right? So you don't need to mug up again. I'm taking example of concave mirror, but you can take for convex also. So this is your C, this is your F, P. Before going to detailed derivation, if I have explained earlier, for mirrors, plane mirrors, spherical mirrors, lenses or curved surfaces, we should always take example of a point object, and then you can take example of a linear object. If you know a point object image, right, then you can draw a linear object image automatically. Reason, every linear object would be formed by a multiple point object. So as long as you know the formula for point object, you can derive for linear object too. Most of the books, they will describe about only linear object, and we mug it up only for linear objects. Some for mirrors I have not seen in any books, at least whatever I read, that they talked about point object image, and image for that. They did not derive this formula for it, right? For lenses they have, for curved surfaces they have done it, right? So we will take it, and then linear object is nothing but just millions of point object. So we take 2 points A and B, and if we form image for those 2 point objects, we join, and that becomes an image. So here, excuse me, so here let's take this point object here. It is O on principal axis, okay, and draw a ray, take a ray which is going like this, and then forming a equal angle of incidence and reflection. Okay, so if this is point E, let me join C and E. Okay, so CE would be normal to that surface, because radius is always normal at 90 degree at perimeter of the circle. So CE would be normal, and this ray would be forming incidence angle theta, and it will form an angle theta, as a angle of reflection, and it will go cutting somewhere at this point, principal axis. This is first ray, and we have read that we need to know, not read actually, there's no we know it, right? To identify any point you need minimum two lines. Wherever they intersect, that is your point. Otherwise there could be infinity of points in a single line, so you need two intersecting lines. So one ray we took it. Another ray, generally we take the ray which is coming from object and going through C. C is center of curvature. So again C will be going like this and coming back, right, and going back. Why? Because this is again normal to that circle, or like this curve. So these two rays, reflected rays, they are cutting somewhere here, which is I. Okay. Now we can, like this distance you can call V. This whole distance OC, this whole distance from O to P, you call it U, okay, and other R and R. So now we will use simple geometry, and we will use simple geometry to prove this formula. Assume this angle alpha, this angle beta, and this angle gamma. Very simple. You form a triangle. So beta would be sum of alpha plus theta, because this is outside angle, right? So beta would be alpha plus theta, and gamma would be, for this triangle, CEI. CEI, gamma would be, because this is exterior angle, beta plus theta, right? So if you remove theta from this place, what does it show? How to do that? You subtract 1 from 2, right? So beta minus gamma equal to alpha minus beta, which says 2 beta equal to alpha plus gamma. Simple, very simple. We use the property of exterior exterior angle of a triangle, and theta equal to theta, I equal to R, which is like angle of incidence angle. We proved that. Again here we will use the caveat which we assumed in the past example. We will use that throughout. That assume this is a small curvature. The curvature of the mirror is small. In that case, if the curvature is small, these angles alpha, beta, gamma, they will be very, like, you assume like it's this, so they will be very, maybe 5 degrees, 6 degrees, 7 degrees, right? So if you know trigonometry, for small angles, if they are represented in radians is like pi, right? Then tan alpha equal to alpha, tan beta equal to beta, tan gamma equal to gamma. I mean, tan of angle is equal to, actually almost equal to angle in radians, right? So we can write here 2 times tan beta equal to tan alpha plus tan gamma. Okay, we use this caveat, and we use our trigonometry and geometry. Now we will simply put tan beta alpha gamma values, which is like perpendicular divided by base, right? So let's draw a perpendicular from here, right? And P and this point would be same. So let's say this is the height, EP, okay? So 2 times EP is height, h divided by, this is beta, so triangle ECP. So CP is your nothing but 2f, right? So 2f. Sorry, let me use first, you know, in terms of names, EP divided by CP. Tan alpha would be EP divided by OP. OP plus EP divided by IP. Alright, now what we have to do, because these are all magnitudes, right? So we have to put modulus of it, right? So we have to, because this is true only when everything is a positive. So when we put EP is height and CP is nothing but U, right? Distance of object. So we follow sign convention, right? And we will put these values in terms of U, V and F, but with sign. Okay, then 2 equal to EP. EP is H, so H is on the, above the x-axis on the positive direction of I, so it would be positive, so H is anyway positive. CP is nothing but 2F, which is negative, right? Because if you know, anything we measure from P to the left side, which is opposite of the direction of rays, then it is negative, right? So in our case, everything we measure from P to left side, which is opposite of the opposite of direction of the ray, right? So 2F would be negative, and then plus H minus U to H minus V. So you see, 2 is HH would be removed. So we got the formula, and because we have minus sign all across, so we got the formula 1 by F equal to 1 by U, 1 by V. Now, so very simple. You can say you know it, so you proved it, but how do I remember? So when I wrote these formulas, I wrote three things: B, M, C. C means caveats. So you need to mug up, along with the formula, you should always mug up caveats associated with that formula. Because if that assumption is not true, those formulas will also not be true. So in tricky questions, in competitions, they try to give, they don't take a small curvature mirror, they will take something else, and you will use this formula and you will screw up. Alright, so the caveat was that this is a small aperture, and in small aperture case, these angles alpha, beta, gamma would be very small, and alpha becomes tan alpha, and that's all. So as long as you remember these three things, you're fine. Alright, so summary: B, basics, you're from previous classes, trigonometry, geometry. If you've forgotten, please revise, in summer vacations, and most of the people remember it. Milestones, okay, whenever you think like, you just close your eyes and start doing this derivation of that formula, you should remember one or two milestones, because this is small derivation, only one milestone, that somehow you have to reach at level where you can do you can play with trigonometry, like 2 beta equal to alpha plus gamma, and then take it to tan alpha, and then use caveat, and then put the values of tan alpha in terms of trigonometry, like in terms of lengths, right? You can ask here one very important question, that we have already put sign here, right? Then why, when we will be using these formula in numericals, we will again put sign. So answer is there itself. This condition, original condition is this one, 2 times EP by CP, EP by OP plus equal to EP. So this is because it just has, well, it is length in a, like it has just modulus, right? So if we put sign first time here, okay, knowing that u is negative, okay, and when we actually put value u equal to 25 minus 25, it becomes positive. Okay, that is the reason we do it. If we put sign only once at the time of numerical, this will not, this whole first condition, this will not hold true. This would become wrong. Okay, and whatever value comes, let's say we are trying to calculate v, we will indicate what is the sign that tells you where the image would be formed. Okay, all right. Now let's go to the next derivation, which is m equal to I by O minus V by U. Okay, before going to that, if you want, I can prove taking an example of linear object. Okay, and what do I mean here? Actually, I could have drawn there itself. This is your C, this is your F, P, A, B. Okay, so now we already learned that if B is your point object, its image would be formed somewhere here, right? We learned that. And if I take another point object A, okay, and then try to see where the image of A would be formed, right? This is B dash, and if I join A dash and B dash, okay, then it becomes a linear object. So we just need to find where, if point object is not on principal axis, where the image is formed. Believe me, people have misunderstood that. They say that AB is a linear object. Actually, in this example, we are proving that if A is a point object which is not on principal axis, then where is the image is formed. Okay, and while doing that, we will draw a perpendicular from A to B. We are not proving for B, and we will come to the conclusion that for A also 1 by B plus 1 by U equal to 1 by F. That holds true. So if A is also formed at same distance where B's image is formed, so because this is a, we put a perpendicular, right? Then this A dash B dash would be also a perpendicular. I mean, that would be also image. I am not sure you guys will appreciate this, but the point is, nobody told you that AB is a linear object which is perpendicular to principal axis. So how do you know that if you put a linear object normal to the principal axis, it will form a linear erect image at principal axis? Nobody proved that. We will prove here. So I'm sure you'll now get confused. Actually, this is tricky thing. Can you prove if this is your AB, how it would be formed? You will not find in this book. But you can, if you know the derivation of a point object image formation, then you can actually calculate everything for this AB, which is at angle 60 degree. Are you sure that AB would be, if this is 60 or you can say 120 from principal axis, what would be the angle for A dash B dash? You can calculate it. Okay, but let's not go to that level 3 questions. I'm just trying to tell you that we took a point object A, we put a perpendicular which is at B, and now for A we will take parallel line, parallel ray which is going through okay, hitting plane mirror, sorry, hitting mirror, and because now we have learned that it will go through F. Okay, got it. Now another ray we will take which will pass through center of curvature. So A dash B dash, this is your F. True. Let's say this is point E. Draw a perpendicular here. Okay. So now we know that A dash B dash would be formed between somewhere C and F. So in mirror you can calculate all this using formulas, or basic things they used to do it by drawing ray diagrams, and wherever they intersect and you measure the value, right, all that. So we know that it will be formed here. Now, so if you have to do similar derivation for this kind of, again this is not a linear object, I put a perpendicular, but it will prove that B is also, if B could have been, or it would have been another end of that linear object, then it will be formed at B, so then it becomes a linear object. Okay. So now in this example we will, looking at this, we will take two triangles and we will prove that they are similar triangle. I mean, not sorry, similar. How do you say? Those triangles are, yes, similar triangles. Triangle ABC and A dash B dash C. Why? Look at these two triangles. Okay, so these two are similar triangles, and reason is very simple. I mean, if you can't, looking at the diagram, if you can't figure it out, these are opposite angles. This is 90 degree, we put a perpendicular, and third would be automatically same. But if you don't know, this angle would be this angle equal to this angle, because those are alternate angle, because these are two parallel lines. Similar. So what does it say? We took these two triangles. So what does it say? That AB divided by BC equal to A dash B dash divided by CB dash B dash C. Correct? Now we took these two triangles, we can take these two triangles also. They are also similar triangles. So EP, let's say this point is P dash, EP dash divided by FP equal to A dash B dash divided by B dash F, this, right? Ratio of this divided by this would be ratio of this divided by this. Now we will assume same caveat here, because the mirror is same. If this is a small curvature, then P dash and P would be same. Okay, so we can replace P dash is just a perpendicular from E to P dash. So this would be P. So we can replace wherever we have P dash, we can replace with FP. I've already done it. Okay, sorry, this EP dash. EP divided by FP. Alright. Now we purposely, because AB equal to EP, which is H, AB equal to EP, and BC so these are two main equations. Now AB equal to EP is H, so I don't want to write it one more time. I can write here in place of EP, I can write AB, right? So this becomes AB. So now AB, if you bring A dash B dash here, so BC divided by B dash C would be equal to FP divided by B dash F. Right? Clear? Because AB divided by A dash B dash. That's length of this and length of this. Both are coming in these two equations. So now that indicates BC divided by B dash C equal to FP divided by B dash F. Now if you put, we have come again to the same point. We have to put BC, B dash C, all those lengths in terms of U and F, because we have to find relation between U, V and F. So BC is nothing but PB, BP minus CP. CP is your R, which is 2F, and BP is U, because it's a distance of object AB from pole P. And again we have to put sign. So what I would do, BC is equal to minus U minus 2F. Okay, because U, BP minus CP. So this minus and these are two with sign, divided by B dash C. So B dash C is nothing. V is this B dash to P. So V minus F. So we will put here minus V minus FP. FV we know this is F, and B dash F. B dash F is, I'm sorry guys, B dash F is actually minus V minus F. Here it was B dash C. So B dash C is actually 2F minus V. So this is minus V and this would be 2F. If you do all this cross multiplication, you will come to know that UV equal to UF plus VF. Now divided by UVF, so this becomes 1 by F equal to 1 by V plus 1 by U. So here caveat remains same. Milestone, two milestones. First thing, you need to, the way we took in the last examples, alpha, beta, gamma, where we have, here we have to take similar angle property, and which two similar triangles property, right? Similar triangles property, and which two triangles I have to choose. Listen carefully, because this is applicable across lenses, any type of mirror. If you see any derivation, they will take like this only. Take two triangles, one which is formed by first ray, okay, like ray going through C. So C is going, image A dash B dash is formed. So A B C, it is going through C. So A B C, C B A. Second triangle you have to choose. So you have to use the property of similar triangles between this and this. Now with so much of rays, you get confused which were those two triangles. Second, you should take the second ray which is reflected. So this ray goes like this and then it reflects. After reflection, it will form with image, right? So A dash B dash F would be one triangle, and opposite to that, reason we take opposite to that, because this ray, height is equal to this, right? So next time you have to take this triangle and opposite to that. So you need to prove, you need to take use the property of similar triangle between these two, and in both you will see this part, ratio between this and this would be common, right? And using that we equate rest of the things. That's all. All right. And again, in this formula, basics were, you should know, here actually there is no basics because it was simple, or geometry, that was your basics, but we talked about it. All right. So here also we put signs and you will get it. So milestone, caveats, very simple. Now let's prove M equal to I by O equal to minus V by U. So you can do it actually, even in using these triangles, it would become a little lengthy, but because you saw that we found some relation between AB divided by A dash B dash here, AB. So if you take BC out, right, and put A dash, so it would be B dash C divided by BC. Okay, so out of this, if you somehow try to remove 2F, right, then you will find A dash B dash divided by AB equal to minus V by U. But it becomes more lengthy. If somebody asks just this derivation, I will, there's a simple way to prove that. Very simple. I mean, that's one line. So now we will form ray diagram O dash, this is your C, this is your F. Okay, so rather than taking first ray, we need two rays, right? First ray which goes parallel to principal axis and then gets reflected, we will assume, not assume actually, I mean, that concept, we always take two rays, but if you know the basic things, rays would be like millions of rays would be spreading from point O dot, right? And we are just picking one of them or two of them. Sometimes we take three, but three is just for validation that it really intersect at the same point where other two rays have intersected. So this time I am not taking a parallel ray which is coming to mirror parallel to principal axis. I am taking a ray which comes from here, and actually it's hitting at pole P, and that principal axis is normal to this mirror, so then it will form a similar, this angle would be same because angle of incidence equal to angle of incidence. Second ray we would take from O and it will pass through center of curvature. So image is formed somewhere here. I can say A, B, and this is your A dash, B dash, previous, right? So, sorry, these lines are not straight. But looking at this, you can easily see that these two triangles, this and these two triangles, A B ABP are similar to A dash B dash P. Simple. 90 degree, 90 degree. These are these are I equal to R, angle of incidence equal to R, and third angle is also same because two angles. Those are similar. It means AB divided by AP, right? AP is nothing. AB divided by AP would be equal to A dash B dash divided by this is A dash, this is B dash. Okay, so A dash B. By the way, AP is nothing your U and A dash P is nothing V. AB is nothing but your linear length of this object, linear object, and A dash B is length of image. Right? Now putting all that with proper sign, and distance measured above the principal axis vertically, they are positive. So let's say if I say A dash B dash is I, so because it is downward, so it would be negative, AB would be positive. So O is length of object divided by AP is nothing minus U equal to A dash B dash is minus I because it's downward divided by V minus V. Okay, so minus gone, I divided by O equal to minus V by U, and this is called M. Okay, so just with one line, one similar angle property, we purposely took a ray which is hitting at point P so that we find these two similar triangles where F doesn't come in picture, and we can directly get a relationship between B and U and AB and A dash B dash. Alright, so all three formulas I think you can remember. Remember these two diagrams, okay, and just if you have to prove M equal to minus V by U, you don't take parallel ray, rather take ray which is hitting at P.